So now that we've plotted our actual prices versus our predictions, and we've generated this chart here, let's move on in our residual analysis to the sister chart of this one. Because in this chart, we can't actually see the residuals explicitly, right? We can see kind of how far the data points are from the cyan line here, but our residuals are actually not on one of the axes. Let's make this much more explicit and plot our residuals versus the predicted values. Let me come up here, add a comment that reads residuals versus predicted values. I'm going to take these lines of code, copy them, paste them below, and now I'm going to modify them a little bit. So I'm going to get rid of this line. On the x-axis, I want the label to read predicted log prices and then slash hat y_i, font size 14. On the y-axis, I want it to read just residuals. And for the title, I want it to read residuals versus fitted values. Now let's update the arguments in the scatter plot. So for the x-axis, you already guessed, it's going to be results dot fitted values. And for the y-axis, it's going to read results dot resid. For the color, I'm going to go with navy. And for the alpha, I'll leave it at 0.6. Now let me hit Shift Enter. So this is the chart that you can compare to the charts that you've seen in the slides earlier on in the lesson. How do we interpret what we're looking at here? Are you seeing any obvious patterns? I think it's actually pretty okay. The residuals look fairly random for the most part, and the residuals are actually centered around 0. So looking at the y-axis here, we can see that a lot of the residuals are centered around 0. The residuals are also fairly symmetric. They don't seem to be systematically high or systematically low. So the model is kind of correct on average. But in this chart, we also see the issue with the high price bracket homes filtering through. No surprise there. Can you spot them? Which data points on this chart correspond to all the $50,000 homes? They're actually right here. You see how this almost traces out a line? These data points on this chart correspond to these data points on this chart. Those $50,000 properties that we're bad at predicting seem to be lining up. Now let's do our next check on the residuals that we talked about. Let's check for normality. Let's see if our normality assumption is satisfied or close to satisfied. Because in the beginning of the lesson, we said, well, we kind of want these residuals to be normally distributed. Let's check out if they really are or not. In the cell below, I'm going to add a comment, and that's going to read distribution of residuals log prices hyphen checking for normality. A normal distribution, if you remember, has a mean and a skew of what? 0, right? The skew should be 0 and the mean should be 0. How do we print out the mean and the skew? We'll take all results objects, results dot resid, get the residuals, and then we can chain a method onto this. For the mean, would use dot mean parentheses. Let me hit Shift Enter. What's printed out here is in scientific notation. So let's round this. Let's say round parentheses results dot resid dot mean comma, and then let's round to 3 decimal places and have the closing parentheses at the end, Shift Enter, and we see here that the mean of our residuals is indeed very, very close to 0. Let me store this in a variable called resid underscore mean. And now let's print out the skew. So results dot resid dot skew parentheses should be our skew. Let's see what that is. Okay, 0.12 approximately. We can also round that, round to 3 decimal points. And I'm also going to store this in a variable, resid underscore skew is equal to this whole thing. So fair enough, the mean is equal to 0. The skew is not equal to 0, but it's not too far off. Now, looking at these two numbers is helpful, but it's even better if we complement this with a plot, with a graphic. So I'm going to use Seaborn here, sns.distplot, distribution plot, parentheses, and then as the arguments, we'll provide our residuals, so results dot resid, and for the color, we'll go with navy again. Now I think every plot needs a title, so plt.title, and then as a title, we'll say single quotes log price model colon residuals. Now let's go with plt.show and see what this looks like. Here we go. Here we see the distribution of our residuals using Seaborn's distplot function. I can come back up here, make this an f string by putting the little f in front, and add our residuals mean and the skew into the title. So I'll go with skew, parentheses, curly braces, resid underscore skew, and mean, parentheses, curly braces, resid underscore mean. We didn't calculate the mean and the skew and rounded for nothing after all. Let's show it in our chart. There we go. So how are we doing? Well, the mean is equal to 0, but that's no surprise. That's actually by design. That's how the regression model's best fit line is calculated. No matter how bad your regression line, the mean is going to be equal to 0 by design. But I think the skew being close to 0 is a result of our data transformation. And I'm going to prove this to you shortly. Looking at this histogram and the estimated distribution for the residuals by Seaborn, what's really comforting to see is that the residuals are fairly symmetrical, right? And they have a fairly constant spread throughout the range. So I think we're doing pretty okay. The thing that you do notice, however, is that this distribution, in contrast to a normal distribution, has much longer tails. So there's more values in the extreme left and the extreme right than what you would see with a normal distribution. You've got a bigger peak in the middle, and then you've got longer tails on either end. So this is where the similarity to the normal distribution is much, much weaker. Okay, so we've looked at 3 charts of our residuals, but I think what we really need to do is we need to compare how these charts look like for different models. Because if these 3 charts are all we've ever seen, we don't really have much context, right? And so on that note, I'd like to pose a challenge to you. I want you to generate these 3 plots, right? So this distribution, the residuals versus the fitted values, and the fitted values versus the observed values for the original model that we had. So this was the model with all the features using normal prices, not the transformed log prices. And after you've generated those charts, I want you to analyze and interpret the results that you're getting back. So I'll give you a few seconds to pause the video and give this a shot. Okay, ready? Here's the solution. I'm going to use the lazy man's approach and copy this entire cell. I'm going to then come here and paste it in. And now I'm going to modify the code a little bit. I'm going to change my comment here to say original model, normal prices, and all features. To use normal prices, I have to not just get rid of this comment, but I'm going to have to get rid of this np.log here. And to use all the features, I'm going to delete indus and age from the arguments under the drop method. Scrolling down, don't need this comment anymore. Don't need these comments anymore. And then for the scatter plot, I'm going to go with a different color. I'm going to go with indigo. For the labels on this chart, I'm going to say actual prices, thousands, predicted prices, thousands. For the title, I'm going to say actual versus predicted prices. Coming down, I'm going to delete this line of code, which we don't need. For our second chart, I'm also going to go with indigo. I'm going to update the labels. And now all I have to do is add the distribution graph. So that's going to be a residual distribution chart, which I'm going to grab from up here. I'm going to grab these lines of code here, copy them, put them down here, paste them in. Again, change the color to indigo to set them apart a little bit. Update my title. Let's have it read residuals and print out the skew and the mean in the title. And that's pretty much it. The coding side of this challenge was pretty trivial because we're reusing a lot of the code. But let's take a look at what the charts look like and see what the differences are between what we are doing here and what we did earlier. First up, our actual versus our predicted prices. Now, visually, the first graph and this one here actually seem quite similar. And that's no surprise, given that the correlation between the fitted values and the observed values is around the same. Yes, it's a bit worse. We know that from the R-squared that we calculated, and it has a little bit lower correlation, but it's not super dramatic on the differences. The predicted and the actual values are actually fairly close to the cyan line, as they were with the log prices. Now coming down on the second chart here, this one's much more interesting. Here we're definitely starting to see a little bit of a difference. Compared with the log prices, the cloud of residuals looks almost like it's got a little bit of a parabolic shape to it. It's kind of subtle, and you almost have to kind of squint a little bit. But what we're seeing here doesn't look entirely random. This provides further justification that the log transformation for the target values that we did was indeed appropriate. Now, what about the third chart? What about the histogram and the distribution of the residuals? Coming down, we see that, yeah, the mean is equal to 0, but what about the skew? And here we need to see that with a skew of 1.5 approximately, the distribution of the residuals is actually fairly lopsided. This makes this distribution a lot more dissimilar from a normal distribution because the skew of a normal distribution is 0 and we've got 1.5 approximately. A distribution of residuals that's not close to a normal distribution makes things much more difficult when it comes to making predictions and making forecasts, which is ultimately what we wanted to do, right? This is the assignment that our boss gave us in our imaginary real estate office. So I hope this was a helpful contrast to what we saw earlier and provides a bit more context. But I want to show you one more example because before we finish this lesson, I want to show you the kind of pattern that you could see in your residuals when you're missing important features or omitting kind of key variables in your regression. So let me come back up here, copy this, paste it, and then I'm going to update my comment here. I'm going to say model omitting key features using log prices. And now what I'm going to do is I'm going to start dropping quite a few features from our data set. I'm going to drop not just indus and age, but I'm also going to drop lstat, I'm going to drop rm, I'm going to drop nox, and I'm going to drop crime. Now, we said we'll use log prices, so I'm going to add np.log back here where we're getting our prices. And then just as a review, you don't actually have to stick to the named colors that are in matplotlib. You can actually specify any color you want, any shade you want. If you go to a website like flatUIcolors.com, you can grab a particular hex code that identifies a particular shade of a color. The hex codes always start with this pound symbol, and then there are 6 letters or numbers following that. So I'm going to take alizarin here, which I can then paste in here where I've referenced indigo. So C is equal to pound E74 C3C. This is this shade of alizarin that we've copied from the other website. Coming down, I'm also going to replace the color in our second chart, so that way each of our models has a certain theme going on. And I'm also going to delete this block of code at the bottom. Finally, I'm just going to update the title here. So I want that title to read actual versus predicted prices with omitted variables. And the very last thing we have to do on the labeling front is change our X and Y labels. So these are going to be back to log prices. The X label is going to read actual log prices, and our Y label is going to read predicted log prices. Now let's take a look at our charts. There we go. So this is interesting, right? As before, we see this banding here on the top right with our very expensive properties at 50,000. We also see that, as expected, the correlation between our fitted values and our observed values is much, much lower because we're leaving out a lot of information, a lot of explanatory features from our model. But not only that, we see this kind of like banding here. So you've got all these data points lining up here and here and even inside this cloud here. Scrolling down, we see that this is even more extreme when we look at the residuals versus the fitted values. Here you can see the banding very, very clearly in the residual chart. Instead of a completely random distribution of residuals, what we see in this chart here are clusters. This is a very, very clear pattern, and it's telling us that there's some important information that's missing from our model, and this information has somehow found its way into the residuals. And this kind of brings me to my final thoughts on the banding that we see with the $50,000 homes. My hypothesis as to why we see these properties lining up like this is because there's something maybe missing from our model. Maybe there is some feature that these homes all have in common, or there was something in the way that the data was collected, or there's some sort of interaction between a feature of these homes that we're not capturing in our model. If I wanted to kind of dig into this further and improve this model that we have further, this would be one of the things I would be looking at. This would be something I could dig into. But we have more important things to do. You and I, we're going to be moving on to bigger and better things. We're going to be moving on to making predictions from our regression model. This is what we ultimately set out to do, right? I'll see you in the next lesson. Take care.